Hey everyone, I hope you all are safe and doing good. So now you are aware about linear search, binary search, and the lower bound and upper bound concept. How to implement lower bound, upper bound with the binary search. Got it? Now in this lecture, we will see some questions, lead code questions, and these questions has been asked in those top tech companies, even FANG companies, Amazon, Facebook, Netflix, and these companies, right? Okay, now very first question. The prerequisite for this lecture is you should have knowledge of binary search and lower bound upper bound. So if you haven't watched those lecture, please go through those lecture first, the previous lecture, then come to this. When once you go to Google and you just search lead code questions on arrays, and you just click on the first link, lead code, and once you click on that link, leadcode.com, there would be problems related to arrays. Now we will see. We are not going to in that much like hard problem right now. We'll see basic one. But see, go for this one. Search insert position, lead code 35. If you click here, you will be redirected to this page. So there is a problem. Search insert position. What is the problem? First, read out this carefully. So the problem given is, see, given a sorted array of distinct integers. Distinct integers. Integers are not duplicate in this case. Now, what you need to do under target value, return the index if the target is found. Return the index if the target is found. If not, return the index where it would be if it were inserted in order. And see, the condition is you must write an algorithm with log and runtime complexity. So we know binary search is log n. But first we'll see brute force, because if you don't know the optimized approach, then and in interview also, if you go through this thing, first you can tell the brute force approach, then how you can optimize that thing. So the interviewer will come to know that okay, you know everything. It's not like that you have just like cram these things and all. You know the logic. Okay, so first go through the brute force approach, then optimize that, go for better approach, optimal approach, and tell the time complexity and all. So this will really help you in interview. So first, let's see. Now what is the question? See, example, if input is array is 1 3 5 6 and target given is 5. So if see, return the index if the target is found. So here we have the target 5. So return the index. Index of this is 0 1 2 2. 1 3 5 6. Target is 2. But here there is no 2. Means where you can insert this 2 without disturbing the order, because this is sorted array. It's not unsorted array that you can insert at end or front or a specific position, or no. You have to find out that particular position. So where we can insert if the array is this 1 3 and 5 and 6. So where you can insert this, target is 2. So obviously this is 1. After 1, see, the element is 3. So it is greater than 2. So definitely I can say that 2 would be somewhere here. After 1, before 3, something like this. So index is 0 1 2 3. So I cannot say some between 0 and 1 there is there any other index like 0.5 or something like this? No. So where you can insert? Obviously after 1, so at this index. So we can insert 2 here, 3 would be here, 5 would be here, and 6 would be here. This would be the array, right? If suppose in the same array, target is 7. See, 1 3 5 and 6. So same array is given, and now at this time 1 3 5 and 6, target is 7. So first brute force approach is simply we start searching from here. See, this is 1. Okay, it's less than 7. Move next. 3 less than 7. 5 less than 7. 6 less than 7. Now end of the array. So definitely it is greater than everything. So here you can insert. So whatever the array of length, that would be returned in this case. The index would be that. Right? So how to write down? Just think the logic. One by one you go through this. If here suppose we were supposed to insert 2. Insert position you have to find out. So 2, what is the position? It's 0 1 2 3. Index would be 1, because here only we can insert 2. Yes or no? If suppose you want to insert 4, the target is 4. 1 2, it is 5. So somewhere here we can insert 4. But there is no 1.5 kind of index. So after 3 we can insert here. Here we can insert 4, 5 would be here, and 6 would be here, 7 would be here. If 7 is there, 7 would be here. So index would be 2. So can you just frame a pattern or the logic? We are searching, we are starting from here. Once you find the index, the element which is greater than the target element. Here the target was 2. 3 is greater than the first element which is greater than 2, the first element. Or you can say the smallest index, where the smallest index where the element, this element of the array is greater than the target. Target is like whatever the target. Yes. Oh, here it is given there are distinct integer, means there is no duplicates. But suppose suppose there are duplicates. The array is something like this: 1, 3, 3, 5, 6, 7. Right? I want to insert again 3. This is the case. What will happen? There are duplicates. Or even in this case also you can take this. I want to insert 3. Where you can insert this 3? Obviously, at 1, at this index, no. Then index 1, it's 3. So I can insert 3 here, yes? Yes or no? Because this is equal to 3. So I can insert this 3 here, this would be here, this would be here, and something like this. So index would be 1. If in this case I want to insert 5, this is the array. Okay. Let me just clean this. And 1, 1, 3, and 5, 6. This is the array, suppose, and I want to insert 5. Now duplicates are allowed. Okay. So you have to find out the position where you can insert. So same position. 1. Okay. Check this element is less than 5. Right. Now go for the next element. 3. Go for the next element. Yes, it's 5. So it is equal to 5. Here we can insert. We can, if you go for here 6. Maybe you say that here also, ma'am, we can insert 5 and there would be 6. Okay, that's also fine. But why to go further? Why to go for more computation? Because just find out, because obviously here also we can insert and here also we can insert. But in terms of like the time, execution time, if you insert here, I'll not compare the next one. So definitely it will take little bit less time, little bit you can say. But it would be, yeah, definitely better. That's why I'm saying that the smallest index where the element is, you have to find out the smallest index where the element, array of element is. Now we can say either greater than or equal to target. Now this 5 is equal to 5. Yes, I can insert this 5 here, this 5 would be here, and this 6 would be here. So you have to find out, you can say the smallest index where this element of the array, this ARR of I greater than equal to the target. That's it. Yes. And this is nothing but we have discussed, this is lower bound concept. In lower bound also we find out what? The smallest index where the array element is greater than or equal to the target element, that is lower bound. But suppose if you don't want to apply lower bound, simply with linear search also we can do this thing. How you can do? Let's write down. Now, loop in linear search, we start searching from here. We don't go for binary search or all. So I would be 0 and I is less than whatever the array dot length. And then I plus plus. Yes. Now, where to stop? You have to if check. If array of I is greater than the target element. Target is whatever the target element. Either greater than or equal to. Then simply return I. Simple. Yes. That is the insert position where you can insert this. Here you can same thing. If I want to insert here again 3. So where you can insert? Obviously this place. So search this. Is this element greater than or equal to target element? No. Is this element greater than equal to target element? Yes. So here I can insert. Just return this I. Simple. If I want to insert 13 here, so there would be no like here this element, check this, and here we have suppose 7. Check this, is it greater than equal to target element? No. So end of the array. Now we return what? Whatever the array length. Here 1, 2, 3, 4, 5. So array length is 5. So here I can insert at fifth index. So at last after this, you can simply return whatever the array dot length. Just to handle that case. Array dot length. If this condition satisfied, okay, return the index. Otherwise, if this condition not satisfied, if that element is not there and it is, you can say, the greatest of all the element, because 13 is largest element here. So simply we know that 13 we can insert here itself. So simply return array dot length. Yes. If I want to insert here same, you can just check 2, or you can say here I want to insert 4. So 4, I can say that definitely I can say 4 would be here. Okay. So check, is this 1 greater than equal to target? No. Next, is this greater than equal to target? No. Is this greater than equal to target? Yes. So as soon as you find the first element which is greater than or equal to the target, just return that index. We know that this is my insert position. So here insert this I. So 0, 1, 2. It will return simply 2. So definitely here you can insert 4, 5 would be here, 6 would be here, and something like this. Okay. But we just have to find out the insert position. That's it. So this is the linear approach. But the thing is, they want you must write an algorithm with log and runtime complexity. And this will take, because the loop is running from 0 till length of the array. Okay. So basically you have to check the loops and number of comparisons. Number of comparisons means basically how many times comparison we do this comparison. Or you can say this condition is being, you can say, executed. If array is 5, so we check this loop will run till 5. If array is of 10 elements, in worst case I'm talking. Okay. In worst cases, I want to insert here 13. So definitely I have to check all the elements, and at last I can insert. So you have to go through, traverse all the elements. So it depends on the size of the array. So basically the loop will run n times. It depends on the array length. Okay. Simple if statement is not, it's not like that this loop will run for n times and this will also run n times. No, and it's n square. This comparison would be done. It depends on the this only. Simple if statement is going to take constant time complexity. Okay. It's simple if statement within the for loop. So now you have to check how many times these statements has been executed. Obviously n number of times. So linear in this case order of n. But now you have to cut down this. Now better approach is go for binary search, find lower bound. Simple. And that thing we have seen. How to find lower bound. Okay. You can go through that lecture. Just copy paste that lower bound code and you will get the insert position. Because lower bound is nothing but same. Lower bound is what? The smallest index where the this array of I is equal to greater than equal to whatever the target. And this is exactly my search insert position. You got it? So see, this is the lead code question. But if you are aware about the concepts, binary search, lower bound, upper bound, these concepts will really help you to solve many lead code questions. Now let's code this. So in our project, this data structure and algorithm, let's create a new Java class, search insert position, right? And let's take an array here. So let's take an array. So we just have a method insert position and we were passing array and whatever the target is, right? So let's here define this method. It will return the index. So return type is integer insert position and we are passing here array. So ARR and whatever the target, suppose X. I'm taking here. Go for linear search at first, suppose. So simply, this is the naive approach. If you are not, you are just a beginner. So simply the brute force approach, what anyone can think is this one, right? So this is the simplest one. Loop will run till 0 till the end of the array, and if whatever the array element, if greater than equal to whatever the x, your target, simply return that index. That's it. Otherwise, if this condition is not satisfied, in that case, after completing this for loop, you simply return here whatever the array dot length. Simple. So if I'm returning this here, so let's just store this into a variable, suppose position is equal to this, and we can just simply print this position. That's it. Let's run this. And for 2, what it will give, let's run this. It should give 0 and 1, because at 1 first index we can insert 2 after 1. So see, the position is 1 itself. Now again, if I go for suppose 0, where I can insert 0 before 1, so it's like at 0th position. So position is 0. If I search for 3, see, I can insert here at 1, because here itself I can insert. Or we can say that if element exists, then also it will return the, you can say what according to that definition, return the index if target is found. So if target is found, here we got the target, so it will return that index only. Or if you want to insert that, the same position is there. Here also you can insert this 3. If suppose one more 3 I have, let's run this. It will again give you the same, like 3 only. Although the question is saying array of distinct integer. So this is not according to the question. We have taken duplicated value. So let's remove this. Now, if I want to insert 13 or 31, so definitely it is the largest among all the array elements. So at last we can insert, that is fourth index, 0, 1, 2, 3, fourth index. You got it? Or if suppose the target is 6, then what it will give? If the target is 6, then 0, 1, 2, 3. Here I can insert the 6. So position is 3. But yeah, we know that it's taking the linear time. So you have to solve this in log n. If you want to submit this you can say code there. So let's submit. Let's just copy paste this and insert position this thing and paste here. So sorry, it's the see the array name is here the nums. So please you have to do the required changes. Nums target is, it's not x, here the name is target. So it should return nums dot length. I'm going for linear search, but obviously you must write an algorithm with log n. So let's see what happens. If I run this, then hopefully it will run. Compilation error and reached out of file while parsing. Okay, we have just removed this parenthesis there. So run this. Now see. Now it will run. Oh, got it. This is not ARR. This is the array name is nums. Sorry, you have to change everything here. Here the array name is nums. So now run this. Now see, accepted all the cases. If you submit, okay, it is fine. But if you submit, then the algorithm is taking order of n time complexity, right? And we have to write in order of, sorry, the in log n. Okay, so now you have to change it. If you analyze the complexity, then this, the time complexity is order of n. It's a linear line, right? There you will get analyze complexity and you can analyze that. Now I'm going to change my solution. So simple, you can go for that lower bound. I have done that thing also. We have done, this is the lower bound approach. We have done how to find out lower bound. Okay, so just copy paste this thing. And first let's just try to comment out this, and we now take one more method. The same static insert position I want to find out. And here I just want to follow that approach, lower bound approach. So I'm just going to copy paste this code, whatever the lower bound code. This thing we have already discussed. So just copy paste this, right? Return low, or if you are not comfortable of returning low, if you're not getting, I've told you, you can simply take an answer at first the position. What is the position? Suppose I'm taking here, just delete this if, and here I'm taking int pos is equal to at first whatever the array dot length, hypothetical value at last. Because if it's greatest of all the elements, then definitely we can insert at the last itself. Low greater than equal to high, find out mid. I hope you know the simple concept of binary search. Find out mid. If array of mid is greater than or equal to x, see it's greater than or equal to x, then means we can say this may be our answer. So our position, let's update the position is equal to whatever the mid, because this is either greater than or equal to, right? So if it's equal to x, then you can just one thing we can do, we can just if it's equal to x, then we can return the index according to the question, right? But here still we cannot return whatever the mid is, because if it's equal to x and array are of having some duplicate value, then we cannot return. But if we know that arrays are of distinct values, then we can definitely return that thing. So here rather than this, we can just return. So here if I want to go search for 3, suppose, so as soon as it find 3, it should return. Okay, so we can write down one more if here. If this arr of mid is equal to whatever the x value, then simply return mid. That's it. This is the situation when array is having distinct integer, distinct, no duplicate elements are there. Else, now in else part, else if array of mid is greater than x, then we can say that x would be definitely in the left side, left portion, right? So if it's greater than x, then I can say that yeah, it may be my answer. Okay, because it's greater than x. It may be my answer, but I'm not sure because I have to find out the smallest index where our mid or the element is greater than x. Then high would be mid minus 1, else low would be this. And at last, we can simply return whatever the position is. That's it. Right? Here. So for same, for 3, if I run this, it will give you the target is 3. Sorry, it's 1. Because, see, 1. Here itself I can insert, or 3 is already there, so it will return simply this thing. And if I want to insert here, suppose 4, then it will give me 1 3 after this 0 1 2 2. Yes, if I insert here 41, then it will give me obviously 1 2 3 4 array length. It's 4, so it's running, right? Now if you copy paste this code there, at so you just copy paste this thing in my lead code. So here, rather than writing this, just remove this and copy paste this. But here you have to change array length, so just change here if you have nums. So I have changed everything. Let's see, let's run this and see if it's working or not. Okay, we have just one thing. Let's here, we have just removed one this curly bracket, so you have to uh, insert one curly bracket as well for the class. Let's check. Okay, passed with all the cases. And now if I submit this, then okay, fine. But here one more case, maybe they can say there these there we are not having, interviewer can say there we are not having distinct elements. Suppose I'm having here something like this, the array is this, and the target is again 3. Target is equal to 3. So if you go for this lower bound and if you run this right now, if I run this, so we are finding out the insert position. So it is giving me 4. Why 4? Because I can insert 3 here itself after 1. I mean 0 at one index only. Why I would compare next till 4, till fourth index? That's useless kind of thing. So in this case, if array is having duplicate elements, array is sorted, then obviously we cannot say that if array of mid is equal to x, return mid. No. Yeah, in this case, see, its mid is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So suppose array is something like this and the target element is, again I want to insert 3. So where is the position? Obviously here itself. Indexes, I can say that index here is it's 0, then 1, then 2, then 3, then 4, 5, 6, 7. Index is this, right? Now I want to insert 3. So in the previous case, it was giving me the output is 4, because here I can say that low and high, we are going for binary search to find out that lower bound. So low is 0, high is equal to, I can say that is 7. So 0 plus 7 divided by 2, it becomes 3. So here we have our mid. So definitely it's 3. It's equal to mid. So it will return the index, that is, in this case it's 4, it's 3. In the previous case, in our program, we are having one more 3. I have just taken one less 3 here. There are 1, 2, 3, 4, 5. 5 elements are which are 3, but there we are having almost 7 elements, see, which are 3. Okay. So, but I don't want to insert obviously 3 here at third index. I can insert here itself 3 at one index. Okay. So now what we can do is, okay, it is equal to 3, but maybe we want smallest index. So smallest index would be to the left hand side. It may be our answer. Answer at first answer was 8. The length of that. Now answer is updated to 3. Maybe our answer, but I want smallest index. So there may be 3 here or 3 here or something like this. So let's go to the left part as well. So now we will go to the left part. We will not simply return mid. Yeah, it may be our answer, but it's not the answer. I cannot say. So go to the left part. So high becomes, it's 2. So now 0 plus 2 becomes, divided by 2 is, it's 1. So now mid is here. It is again 3. So it may be my answer. So update again this to index is now, for this index is 1. So it may be my answer, but I cannot sure. I want the smallest index. Smallest index would be in the left hand side. So 0 again, it would be 0. So 0 plus 0 divided by 2, it's 0. Yes. So low, mid and high both are here. Now see this element. Is this greater than or equal to a target element? No, it's less than. It's less than, so it is greater than. So I can found 3 to the right hand side. So move to the right hand side. So if you move to the right hand side, then low becomes mid plus 1. Mid plus 1 is 1, high is 0. This is termination condition, because now low is high. Low is more than high. So there is no search space. It will return simply 1. And that's exactly the answer. Right? So you can change it a little bit in this case. This is the case. I cannot simply return it this case. Just remove this. If it's greater than equal to, both are in the same thing. Position may be equal to this, but I'm not sure. Again, go for high is equal to mid minus 1. We want smallest index, so high is equal to this. Now if you run this, then for 3 it will give target, sorry, the index is 1. See, it's 1. Right? Okay, so whatever question is given to you, according to that you have to, you can say, frame your this approach. The approach is same. You have to change a little bit. We know binary search. If sorted array, then you have to apply binary search. That is for sure. Search insert position. So if you get lower bound, then you can get the insert position. The difference is what you are given. Distinct elements are there, or what they want. According to that, you have to answer. You have to write your code, right? And for this, we know it's log n. Time complexity would be log n for binary search because we are going for binary search in this case. Okay, one more question is this. Find first and last position of an element in a array, sorted array. And this question is an interview question, has been asked in many top tech companies, even in Meta. See the level of question they ask. So you don't get afraid of the name Fang or Mang. No, they ask these questions itself. If you know the concept, if you know the approach, you can easily solve the questions. Maybe some questions are tough, but not all the questions. So this is the Facebook level question. Find first and last position of element in sorted array. Sorted array, apply binary search. Given an array of integer nums sorted in known decreasing order means ascending order, find the starting and ending position of a given target value. If target is not found in the array, just return -1 -1. I mean the array returning -1, first occurrence is -1, last occurrence is also -1 because element is not there. You must write an algorithm is log n complexity. We know binary search is taking log n, so it's not that much tough. You can easily write. Now see the input. Num is nums. The array is this, right? And they are not saying that the array is having distinct integer. It's known decreasing, ascending order, but it can have duplicate values, right? So this is the array. Target is 8. First occurrence of 8. We know this is first occurrence. This is last occurrence. So index is it's 0, 1, 2, 3, 4. 3 and 4 it will give. Yes. This is the array. Target is 6. We know that there is no 6 here. So just return -1 -1. In this case, nums, it's nothing. Target is 0. So if array is empty, then obviously it will return -1 -1. Right? How to solve this question? Let's see. So this is my array and the target is 8. You have to find out first occurrence and last occurrence. Right? Okay. First, we are not aware about like we are beginner and I'm not aware about lower bound or binary search and also what is the brute force approach? What is that naive approach? First comes in your mind. How to find out first occurrence of a letter? So very simple. Start searching from this. Is this 8? No. Is this 8? No. Is this 8? No. Is this 8? Yes. So at first, what we can do is for first occurrence, I can say at first, the first occurrence is -1 and last is also -1. Because if element is not there, then we have to return -1 -1. So let's say both are -1 -1. Now I got 8 here. Equal to 8? Yes. Okay. Now we have to change this first and last. So check. First occurrence is first. This element -1. If it is -1, change it. So now change it to here 0, 1, 2, 3, 4, 5 with 3. It's 3. Last is also 3. Change both. Both are -1. Change. Right now. Next element. It's again 8. Yes. So can we change both first and last? No. First occurrence would be this only. Last occurrence is whatever the last occurrence like this. So you check. Is first -1, then only change. Now in this case, is first -1? No, it's 3. So we will not change it. But we will change last every time. Because obviously last will be maybe like right now 4, then maybe 5. Here also again we have 8. So last you have to change. So now last change, it becomes 4. The index is 4. Go for next element. Is this 8? No. So we are this like the end of the array is this, right? So now return first and last 3 and 4. This is the answer 3 and 4. If suppose the target is in this case only target is 10. Yes, at first same. Let's take first and last -1 -1. Check. Start with first 5. Is it target? No. Is it? No. Is it 10? No. Is it 10? No. Is it 10? No. Is it 10? Yes. Once you get the element is equal to the target element, check. First is first -1? Yes. Change it. Now it becomes whatever the index 5. Last we always change it. It's 5. Now is the next element? No. So terminate the loop and it will return 5 and 5. First is also 5 and last occurrence is also 5 because only one element we have. Suppose I want to search for 12. At first Last is -1, first is -1. Check from this. Is this 12? No. Is this? No. No, 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 and end of the array. So loop would be terminated. And first and last are still -1. Just return first and last -1. That's it. So this is simple approach. You can say linear search you are applying, brute force approach. But obviously we are going from first element to last element in the worst case, so it will take order of n. That is not a good time complexity linear. Can we solve it with less than order of n? Yes, we can. But for now, let's write down. Have to write down this thing. So see, we simply write. At first, we are having what? So at first, we can have simply rather than taking like two variable first and last, what we can have an array because we have to return it's in form of like array, na? 3, 4, -1. So it's an array having two element. It's not a single variable. So we can have an array. Suppose result is equal to at first -1. Simple. This is my array result. Now the loop would be 0 till this is pseudo code. I'm not writing the exact code here, right? Less than whatever the length of the array and I plus plus because we are following from 0 till the end of the array. Now check if array of I is equal to whatever the target element. If this is true, then we check if again this is obviously first and last. So how to access this element? We know this is array. So array of 0th index, array of first index. So if result of 0 is equal to -1 is -1, then change it. Now it becomes result of 0 becomes whatever the I value is. Simple. And last we change every time. So after this, if this is the case, after this we change the last. So result of 1 is equal to I. It's 1 is equal to I. So every time we change this, and I guess that's it. This is the simple logic. So like if we are having this array, so at first 0 array length is we are having 1, 2, 3, 4, 5, 6. Array length is 6. Condition true. Enter here. ARR of 0. ARR of 0 is 5. It's 5. Is 5 equal to target? Because target in this case is 8. Target is 8. Is 8 equal to 5? No, this condition is not true. Right? So if this is not true, we are not going to enter into this part. We are not going to change anything here. Okay. So this is like maybe closing of this if this. So we'll not enter there. Now I plus plus. Now I becomes 1. I is 1. 1 less than 6. Yes. Again enter here. Is this equal to target? No. So we will not enter here. Again I plus plus. Now I becomes 2. Is this equal to this? No. Now again 3. Yes. Now once I is 3, this condition true. ARR of 3. So here we have 0, 1, 2, 3, 4 and 5. So ARR of 3 is 8. Yes. Now this condition is true. ARR of 3 is equal to target, that is 8 is equal to 8. Now if this condition true, again enter here. Now see result of 0. So result of 0. How to access this? Obviously 0 and 1. Is this -1? Yes, it's -1. The result of 0 is equal to I. I right now is 3. So update it with 3. And irrespective of this, because we are not writing this in else part. So after this if, directly control will go to the next statement, whatever is written after this if below. This is not in else part. Take care of this thing. Don't write this in else part. Like if this is true, then only go here, else go here. No, this last we will update every time. Once you find out this, as soon as you find out this, you have to update the last because we want to find out the last occurrence. So keep moving, keep updating this last till you get the last occurrence. So this becomes also I. So it becomes 3 and 3 now. Now I plus plus I becomes now 4. Is this condition true? Yes. Enter here. ARR of 4. Is this true? Yes. It's again 8. So this condition also true. Control will enter here now. If this condition true, result of 0 equal to 1. Result of 0 is not -1. It's 3. So control will not enter here. Will not update this. Control will go out of this if whatever is written. We have written this statement. Result of 1 is equal to 1 is this, is equal to I. I is now 4, so update this to 4. First index would be as it is. I plus plus, now I becomes 5. 5 less than 6, yes, enter here. ARR of 5, it's 10. Is this condition true? No. You will not enter here. I plus plus, I becomes now 6. Is this condition true? No. Out of the for loop. Just return this 3 and 4, and we know the answer is 3 and 4. But this, we know that taking order of n complexity, linear, in worst case, it's not great. You have to find out, you must have to write down an algo with log n time complexity, logarithmetic. Okay, so we know if array is sorted array is given. Second thing, you have to find something. Find means you have to search something. Searching in a sorted array, apply binary search. Time complexity would be log n. Simple. Okay, but now, okay, you have to apply binary search in this case. This is the brute force approach. Now, go for the optimal approach, better approach. Simple apply binary search. Still, we are not aware about maybe lower bound, upper bound. We know only binary search. Okay, so this is first approach. Second, let's solve this with binary search. Okay, now we have this array. You know the concept of binary search. Simple. Low 0, high is 5, 0 plus 5 by 2, it's 2, mid is here. Now, we can't, in simple one binary search, we cannot find out both first and last occurrence like in the previous case. So first you find first occurrence, then again apply binary search, and we go for last occurrence. Two times you have to call binary search. Okay, so first let's find out first occurrence of target is 8. First occurrence of 8, let's find out. Right? Now, binary search. This is the case. Now mid is like 2. So is this 7 mid element? Check. Is this 7? Because this is 7, this is 8. So mid element, as we know, less than our target element. So we can, for sure, we can say that we will find a target element in the right half because array is sorted. That is for sure. So we just cut down this thing. We have to move. The array is now this. So move to the right half. So this low becomes this. Now low would be mid plus 1, that is 3, 5, and mid is again same approach. It's 4. Mid is here now 4. Check for this. Now 8 is equal to 8. Okay, fine. 8 is equal to 8. So we get one occurrence. So we can say that it may be our answer. Maybe. We are finding first occurrence only. So at first, let's assume first is equal to -1. Because if you don't find anything, you have to return -1, -1. We don't assume first is equal to array length and return array length. No, here you have to return -1, -1. So please, you can say, understand or read the question carefully. What you have to return, -1, -1. If element is not there. So at first, let's assume first is -1. Now, this mid is equal to 8. So this may be my first occurrence. Maybe. I'm not sure that it is my first occurrence. Because maybe to the left hand side we can have more 8. Because array is having duplicate data. Array is not having distinct integer. We can have more 8 here. So it may be my answer. Maybe my answer. So I can just update it to 4. But now, I'm sure that at index 4 now I get 8. If I want to find out first occurrence of this, so definitely the first occurrence I can get to the left hand side only if there are more 8 exist. So the first occurrence is definitely to the left hand side. So that is like the smaller index, obviously. So now move to the left hand side, left array. So just remove this and search spaces to the left side only. So if you move to the left hand side, then high would be mid -1. Low would be as it is, high would be 4 -1, that is 3. So 3 plus 3 divided by 2, that is 3 itself. So we are having this search space. High is also here, low is here, and mid is also here. Now check. This is again equal to 8. Yes. So if it's equal to 8, so it may be my answer because we are definitely, if you're moving to the left hand side, so this is definitely the smaller index, and that exactly you want. The for first occurrence, the smaller index, smallest index. where first time this element occur in that array. So we just update this with 3. This may be my answer. Maybe I can have more 8 to the left hand side. I want first occurrence. So again move to the left hand side. So now low would be as it is, high would become 3 minus 1, that is 2. Now stop. You have to run till the termination of the loop. Now see, here low is greater than high, so we don't have any search space now, because the condition is while low less than equal to high, till then you have to search, because answer exists always between low and high. Once low becomes greater than high, there is no search space. So now at last, what is the first value? 3. Return this. That is my first occurrence of 8. And that's exactly we have. Yes. So this is how you can apply binary search, simple binary search, and go for this. Now, if you want to find out last occurrence, in that case, what we will do? Okay, let's see. I hope this is clear to you. Same thing. We are going for obviously binary search here. But right now, last occurrence. Low and high and mid is divided by 2. So it's 2. Right now is this 7. So in first occurrence, if I want to write down, then it's like the smallest index where the element is greater than or equal to the target element. That is the first occurrence. Can I say something like this? But there are some cases. It's like exactly lower bound, but there are some edge cases. That also we'll see. Okay, but right now we are just going for no lower bound, upper bound. Just forget that thing. We are just applying binary search here. Now, if suppose if the target in this case is 7, suppose same first occurrence I want to find out, not last, still 7. 7 is my target. So first is at first minus 1. Yes. Go for 2. Mid is now 2. At 2, we are having 7. Yes. I can say that, yeah, this may be my first occurrence. So let's update this to index 2, right? But first occurrence is definitely in the left hand side. So maybe there can be more 7 to the left hand side, because I want maybe 7 are here itself, but for first occurrence you have to move to the left hand side. That is common sense. So just becomes high becomes now mid minus 1, that is 1 and 0. So search space is right now this only. We have eliminated this thing, 0 and 1. So 0 plus 1 divided by 2, it's 0. So mid is here. 5. 5 is what? Less than a target element. Target element is right now 7. 5 is less than target element, right? So we will not update that. So we can say that 7, a target element is 7. So we can say that surely 7 would be to the right hand side of this. We can say this. Yes. So move to the right hand side. To move right hand side, low would be obviously mid plus 1. So it becomes 1. High is as it is 1. 1 plus 1 divided by 2. It's 2 by 2. It's 1. So everything is pointing to this 1. Search spaces only we are having one element, right? Now check 7. Yes, equal to 7. It's target element. So we can say that yes, it may be my answer, because definitely if we are moving to the left hand side, that is like the smallest index. So we just update this. Index is now 1. First is now 1. It may be my answer because loop is still running, but I cannot surely say that it is my answer, right? It is equal to 7. Now to find first occurrence, we can say that first occurrence or the smallest index will be definitely to the left hand side. So now move left side, remove the right part. If you move to the left half, then high would be mid minus 1. Now high becomes 1 minus 1, that is 0. Low is 1. But now condition is not true, because now low is greater than high. So terminate the loop. And at last first is 1. So it is my first occurrence. That's it. Yes. Suppose target is 11. Target is 11. Or target is suppose 6. Not 11. My target is right now 6. Right. So now my target is 6 in this case. but 6 is obviously not there. So first occurrence, last occurrence would be -1, -1. Okay. But right now we are finding only first occurrence with binary search. Same, low plus high is equal to mid, that is 2. So mid is now 2. Check 7. 7 is, the element is greater than the target element. Yes, it's greater than. So we can surely say that if it is greater than or equal to a target element, we can surely say that first occurrence would be definitely to the left side, right? So it's 7, it's 6. So 6 always exists, we know, in left hand side. So high becomes now 2 minus 1, that is 1. It's 0. Now search space is this, right? 0 plus 1 divided by 2, that is 0 itself. Mid is here. Check for 5. At mid now we have 5. 5 is less than 6. It's not greater. 5 is less than a target element. If it is less than, so we can say that the target element definitely exists to the right hand side. Yes, because it's sorted array. So now to go for right hand side, we just move our low. So low becomes mid plus 1. 1 plus 1, 0 plus 1, that is 1. It is 1. 1 plus 1, that is, it's 1. Now 1, 1, 1. Low, high and mid is pointing to this. This is only my search space 7. Now compare the 7 with 6. Now target, this mid element is greater than 6. Yes. If it is greater than the target element, so I can say that 6 is definitely to the left part. So again, divided by 2. If you want to move to the left side, search left side, then high would be mid minus 1. High becomes 0, mid minus 1. This is 1, but stop. Because this is a termination condition. Because low is greater than high. So low will, search space is exhausted and it will terminate. At last, what is the first? It's -1 itself. So it will return -1. Because we haven't updated this. Because we didn't get any case that we have to update this. So it remains -1. So it will return -1. That's exactly we want. If element is not there, return -1. This is the first occurrence we are checking. Now go for last occurrence. Now, if you want to go for last occurrence, see, same, I'm taking target is 8 and go for last occurrence. Apply binary search. So same, we know the funda of binary search. We have to find out mid every time. So low is 0, high is 5. 0 plus 5 divided by 2, that would be 2. Mid is here. Now check. 7. Target is 8. Mid element is, in this case, less than 8. If it is less than, so we can surely say it would be to the right part. So to go to the right part, this side, low would be mid plus 1. So it's 3 and 5. 3 plus 5 divided by 2, that is 4. Now mid is here. Check this. It is 8. Yes. It is now, or mid element is equal to 8. So we can say I am finding last occurrence. So at first, we are taking a variable last is equal to -1. Yeah, we can say that this is my answer. First time we got 8. So this may be my answer. But maybe to the right hand side, we can have more 8 because you have to find out last occurrence. So maybe array is something like this. I'm having 8 here, and then 10. So we cannot say that just return this and this is my answer. No, you have to find out last occurrence. So last occurrence is this. Okay. So let's just make it as it is, same array. It may be my answer, but I'm not sure it is the answer. So let's update this to 4. At least we got one thing that 8 exists. So 4. Last is 4. Now, if you want to find out last occurrence, so definitely I can say last occurrence of 8 would be to the right part. Yes. Because if you move to the left part, you will get maybe first occurrence you can get, not last. To get last occurrence, last position, you have to move right. Okay. To move right, you have to do low is equal to mid plus 1. So it becomes 4 plus 1, 5, 5. Now this is my search space only. So 5 plus 5 divided by 2, that is 5. So mid is high here, high and low are here itself. Check 8, 10. 10 is less than, greater than 8. Yes. So 8 can exist to the left part itself because it is greater. So 8 can be to the left part, not to the right of the 10, but left of the 10 in sorted array. So now you have to search it left side. So to go to left side, you have to do high is equal to mid minus 1. So high becomes mid minus 1, that is 4, it is 5. But this is the termination condition because low becomes greater than high, so terminate the loop. Yes. At last now, right now, last is 4, so return 4. And that's exactly my answer. 4. Yes. More cases also you can take. If you want to find out the last occurrence of, suppose here 7. So our target is suppose 7. Last occurrence for 7. Same. We have to apply the same thing. So 0 plus it's 5, it's 2. So here we are having 2. So target is equal to this. ARR of mid. At first, last is -1. So it may be my answer, but I cannot say that it is the surely the last occurrence of 7. It may be my answer. So update this with the index 2. So now for the last occurrence of 7, I can surely say that last occurrence would be to the right hand side. So move to the right. To move to the right, law becomes mid plus 1. So 3, it's 5. 3 plus 5 divided by 2, it's 4. Now mid is 4. Low is here, high is here. So we have this search space now. Mid is here. It's 8. 8. The element is 8 is greater than the mid element. The array element is greater than the target element. It's greater than. So we can surely say that a target would be to the left part of the array. So to move to the left part, high becomes mid minus 1. That is 3. 3. 3 plus 3 divided by 2, it becomes 3 itself. So search space is this only one element. Low, high and mid are pointing to this. Now 8, mid is 3. So at this, we are having 8. 8 is again greater than 7. So we know that our target element is less than the array element, mid element. So it will lie definitely to the left part. Yes. So now again, if you move to the left part, then high becomes mid minus 1. So it becomes 2, it becomes 3. But this is the termination condition because this is 2, this is 3. So low is greater than high. So there is no search space now. Low is high, sorry, low is here and high is here. So in between there is no search space. Okay, at last now, last is 2. So just return 2. So we can say that definitely this is the last occurrence of 7. This is first occurrence, this is last occurrence. So this is how using a binary search, you can simply find out first occurrence, last occurrence. If you want to write down this thing in code, so how you can write? See. So we are having here low is equal to 0 and high is equal to, we know whatever the array dot length minus 1. This is for sure, right? And in first, we are going for first occurrence. First is equal to at first minus 1. So this is the method. It will return int, something int type of thing, array, and we are having target is equal to x. Now, while we know the condition is less than equal to high, loop will run, and in this loop, at first, obviously you have to find out mid. That would be low plus high minus low divided by 2. Simple. Now, if this ARR of mid equal to whatever the target element, then what you will do? If it is equal to x, mid is equal to x, you are going for the first occurrence. It may be our answer, we can say. So we just update this. First is equal to whatever the mid is. It may be our answer, but first occurrence would definitely lie to the left part. So what you have to do now? High is equal to mid minus 1. If this is the case. Yes. Else, if this ARR of mid is greater than, if it is greater than x, greater than our target element. So mid is greater, a target element is smaller. So we can surely say that our element lie in the left part. So you have to do again high is equal to mid minus 1. Simple. Else, if this is not the case, then in else part, simply we can do low is equal to mid plus 1. That's it. This is we are applying simple binary search to find out first occurrence. Got it? So we only change first. If you get that element, whatever the mid element is equal to x, we change this, but still we check in the left part. So we change high as well. Again, if it is greater than x, so we move to the left part, will not change that first this variable. If this is the case, greater than, then high will change, otherwise low will change. We search in the right half. If this condition is not true, in that case our element would be definitely, you can say, less than this mid, because if it's equal to mid, then this condition would be hit. If it's greater than this, if less than, then law becomes mid plus 1. Sorry, in this case, in that case our x would be greater than. If this condition is not true, then x would be definitely greater than mid, so it would be in the right half. So we'll go low is equal to mid plus 1. So this is how you can get first occurrence. Now if you go for last occurrence, there would be a little bit change. This would be as it is. Rather than this, first we are having last is equal to minus 1. I hope you can change it. So you can right now pause the video and try this out. For last occurrence, you can just write down this code, pseudo code. So name we can change its last occurrence. This condition would be as it is, mid would be as it is. Now if this is equal to x, fine. Now we have to change here. It's not first, it's last equal to mid. But now if a target element is equal to mid, then it may be your answer. It may be the last occurrence because element may be one only in that array. But if they are duplicate elements, so last occurrence would definitely lie in the right half. Yes. So in this case, now you have to change here. It would be low is equal to mid plus 1. The condition. Just you have to change a little bit. Right? Now, else if equal to, then this would be executed else. If array of mid greater than x, array of mid is greater than a target element. So we can surely say that our element would be, if this is greater than, our element is less, so it would lie in the left part. So high would be mid minus 1, otherwise low would be mid plus 1. Simple. So you have to change a little bit here, just these two lines. These condition would be same. This is, we are applying simple binary search to find out first and last occurrence of the element. So two approaches we have seen. And you can also get with lower bound and upper bound what? A first occurrence and last occurrence. So I hope till now it is clear to you. Now let's discuss. I'll code this also. This is pseudo code, simple. So let's clean it. And now this is the array. See, 5, 7, 7, 8, 8, 10. If you want to 8, target is 8, lower bound for 8 is definitely this. And this is the first occurrence. Upper bound for 8 is here. If you want to find out upper bound for 8, then this would be upper bound. The first element, which is greater than the target element, that is 10. So this is upper bound. So that to get the last occurrence, we can simply do whatever upper bound minus 1. Simple. So if you know how to find out lower bound, upper bound, simply you can use the third technique as well to get first and last occurrence. Yes, for same. But here, one situation is, suppose here I have 6. Target element is 6, right? And I want to get the lower bound for 6. So if you get the lower bound for 6, then it will return the smallest index. I know, smallest index where this ARR of I is greater than equal to x. It is lower bound. And upper bound is smallest index where this ARR of I is only greater than x, not equal to. We know that these two things we have discussed, right? So 6, if the target element is 6, so smallest index, this condition, where this condition is satisfied, array of I is greater than equal to x. So if this is 6, then what is the smallest index where this condition is satisfied? This. Because in this case, 5 is 5 greater than equal to x? No. 7 greater than equal to 6? Yes. So while lower bound, it will return in this case 0, 1, 1. Lower bound for 6 is 1. But I cannot say that lower bound will give first occurrence, upper bound will give last occurrence. But here it is not true. If it is 6, it should give minus 1. But lower bound is giving us something. And same, if x is suppose 50 or 15, then what lower bound will give us? The first smallest index where this element would be greater than equal to x. So if you go for lower bound, it will return at last the low, and low would be at last here. If element is greater than all the element, then it will return whatever the length of the array, that is in this case 0, 1, 2, 3, 4, 5. It's 6. 3 and 3, 6. So in this case, it will return 6. So these are some edge cases. You cannot simply just copy paste lower bound, upper bound, and it will give you first occurrence and last occurrence. Upper bound is fine. Just do upper bound minus 1, it will give you last occurrence. Lower bound, there are two edge cases. So you have to check this thing. After getting lower bound, you have to check if this lower bound is equal to length of the array. Suppose n. Length of the array is n. If lower bound is equal to length of the array, in this case 6, in case of 5. In this case, element doesn't exist, we know. Right? One more case you have to handle this, 6. Or now lower bound, in this case, if target element is 6, it will give this 1. So you have to check. The element is this 1. Is this the target element we are searching for? If it is 6, then it's fine. Otherwise, element doesn't exist. Or we can say ARR of lower bound not equal to the target element. You simply print here, element doesn't exist, return -1, this -1 for first, because lower bound will give you first occurrence, right? Lower bound for 8 is this, upper bound is this. So lower bound will always give you first occurrence. First occurrence is nothing but obviously same. The smallest index where this element exists at first. Right? Smallest index. So this is the smallest index where 8 occurs first time. Right? But these are two edge cases. Using this condition, we can handle these edge cases. If this is the case, after getting lower bound, you have to put one more condition. This is the case, then return -1. Element doesn't exist. Right? So now let's just code this. How to find out first and last occurrence and all the techniques. Linear search, binary search, and with lower bound, upper bound. 3 techniques. And these are, we know, we are getting lower bound, upper bound, and binary search. That is log and time complexity. So yeah, that's it. Let's code it. So in LeetCode, we are having this question, first and last. So we'll simply take there also the same thing, nums and target, the same name, so that we can easily copy paste that here, right? Now let's just create a new Java class here. First and last position. So let's take this only the same name array that we have taken in the previous case. And here I'm taking target is 3. So first occurrence and last occurrence of 3, right? Okay. Let's go for now linear search. First, simple, the brute force approach. We check with every element, right? So let's name it first and last position and target. So we have a static, so it will return an array. So the return type would be an array, and first and last, the name is this, because -1 it should return. Let's name it nums and this target. At first, let's just have an array of like you can say result is equal to, at first we're having -1 and -1, right? Now the loop would be till we know 0. I is equal to 0 till I less than whatever the length of the array. Sorry, we are taking here nums, not array, nums dot length and I plus plus. Now we have to check if, okay, go for the first ARR of, sorry, not ARR, nums of I is equal to whatever the target element. Then we check if this first, so result of 0 is equal to -1, then update this. This becomes result of 0 becomes whatever the I is right now is equal to I. Just update this. And after this, if simply, not in else part, simply update this result 1 is equal to I, because this will give you the last occurrence. So every time update this if you get. next occurrence of that element. Simple. And at last, after this for loop, after for loop, we are going to return, because we are going to return array. So just return here, return whatever the result is. That's it. Result is an array. So we are returning an array. So definitely here also you have to take an array variable to accept that thing. So suppose I'm taking array of answer is equal to this. And now you have to print. So we cannot simply print answer, because you have to print. We know that two string with two string. So arrays dot two string, and within this we just pass the answer. It will give you, that array format. So this is how it will give the content of this array, whatever the content in this array in string format. So it will give -1 if required, if element doesn't exist. So here we have 3, so it will not give you -1. Let's try to run this, and it should give you 0 and 1. First occurrence is 1, and the last is 2, 3, 4, 5, 6, 7. It's 7, 1 and 7. If you go for an element 5, both first and last occurrence are I think 8 and 8. Yes. If you go for an element 50, element doesn't exist here, so it will give -1 in both the cases. If you go for any element like 2, 2 is also not there, so it will give you -1. But you know the time complexity of this, that is not good. But this is how, like, you have to move. First, directly don't jump to the optimized approach. Try to code the naive approach as well, which is, you can say, the brute force approach. Second thing, let's go for now binary search to get first and last position. So you have to first in this case, in simple one method, you got first and last position. But when you go for binary search, there you have to call 2 times. Binary search, first you get first occurrence, then last occurrence 2 times. Let's code that thing also. So we just comment out this thing, and so we are having this first and last position. So in this case, I am having first occurrence and last occurrence, different. So one method is having for first position, first occurrence, there I'm just passing whatever the nums, and whatever the target is. And second is last position. I'm just passing nums and whatever the target is. Yes. So let's code these two also. Static first position. So simply int, there is no array, it's only first position. So int and first position. So here we have same name I'm taking, nums and target. And like this, we will be having one more for last. Two methods we are having. One is first, one is last position. Now you have to code this. So here, suppose we are having an array, or don't take an array. Let's see that. First, let's code first and last position. So first position. Now, simple, you have to apply binary search. So simply we take same low is equal to 0 and high is equal to nums dot length -1 and int first is equal to, at first I'm taking -1. Now check. While condition would be, I know, less than equal to high, till then the loop will run, and you have to find out mid as well. So same you have to write here. So this is the case, right? So now you have to put the condition. You are getting first occurrence, first position or first occurrence. So if this, sorry, not here we have nums. The array name is nums. Nums of this mid equal to your target element. If this is the case, then it may be our answer. So we can change first is equal to whatever the mid is. But we cannot surely say that it is our answer. Our answer lies, we know that for sure now, in the left half. Because mid is equal to our element. So first occurrence of our element would be definitely if there is more element. and you get the first position, so that would be definitely to the left side. So to go to the left side, you have to move high. High is equal to mid minus 1 for sure. Else if that element, its mid is, you can say, less than, or let's say greater than or less than, any name you can take, any operator, because we will check both the things. If it's greater than a target, mid is greater than the target, means target is a less than mid. So target definitely lie in the left half if target is less than mid. So you have to move to the left half. For left half, again, high becomes high is equal to mid minus 1. And one more case that would be easily handled by else low becomes mid plus 1. Simple. And at last, here we can simply return whatever the first is, like this. I hope you got it. Now code for the last position. Pause the video and now you try this out for last position. So for now, let's just copy paste the same thing, because we have to change a little bit. You don't copy paste, you just try out this. Okay, you have to write everything. Last position. So low, high, this first rather than first. Now you got the last position. So last is equal to minus 1. Condition would be this only. Mid is this. Now, if this is equal to target, then we have to change last. It may be our answer, may be our last occurrence. So last is mid, but we are not sure. To get the last occurrence, you have to move to the right half now, because last occurrence would definitely be to the right half. So to move to the right half, low will become mid plus 1. So now we have to change this. Now low is equal to mid plus 1. Yes. Else if this mid is greater than target, this would be same, because target is less. So we have to move to the left part. To move to the left part, high becomes mid minus 1, else low is equal to mid plus 1. These condition would be same, only you have to change this thing. Yes. Now return last. Simple. Now we got both first and last. So we have one more, we can say here. So now first and last position. This is the method again, which is calling both first and last position. So in this, suppose we take an array. We take here an array. At first, both are having minus 1, minus 1. So we have this result of 0. Or we can say, suppose we are having here element int first. A variable int first is equal to this. I'm storing that in first and last. So int last, the same name I'm taking. Last is equal to this. I'm not taking any array. Suppose. Let's take an array as well. So the thing is, if see, now think about this. If first is minus 1, I have called this first position, this method, and this returned minus 1. Minus 1 means element is not there, because if there is no first position, then element is not there. So why to call last position this method? No need to search for last occurrence if first occurrence is minus 1. Okay. So this is like, you have to think smartly. If this first is minus 1, no need to call this. So you have to just make a check here. If this first is equal to minus 1, then what to return? Simply return minus 1, minus 1, and result is right now minus 1. I mean, the array is minus 1, minus 1. So simply return this. No need to call the last. If this condition is not true, then we call last. Then we can simply return, we can simply return here what? At first, whatever the first is given, or the lower bound, sorry, not lower bound, it's first. We are not going for lower bound, upper bound in this technique. Whatever the first is there, comma, call the last position and pass here nums, comma, target. Simple. But in Java, you cannot write down something like this. Maybe in C++ it's allowed. You cannot simply write down array initializer, something like this, because this is array initializer. You have to write down here new int, something like this, and then you can use array initializer. Right? So here also, if you don't want to take this result, here also you can return simply -1 comma -1, we know, but this is array initializer, we cannot write down something like this. So you can just add new int, this return new int. You can say that allocate memory to the array. New means, yeah, we are allocating some memory to the array, and then obviously array initializer we can write. So first is as it is, and last position would be, call this last position here. Whatever it will return, that would be your last, and simply return this, right? So it is returning array. So we are having an answer. This, whatever this method will return, we are storing this into this answer, and we are just printing answer, toString dot answer. Let's run this. Target element is 2. 2 is not there in this array. So it will give you -1 -1 C. Yes. If target element is 3, and we are having suppose 0 1 2 3 4 4 3 itself. Let's run this. So it will give you 1 2 3 4 5 1 and 5. 1 and 5 index. Yes. If the target element is suppose 1, it will give you 0 and 0, because only 1 is there. 0 and 0. I hope you got this. So this is how you can go for simple binary search. You have just applied simple binary search to get first and last position. So the time complexity for this would be, you are calling two things, first position, last position. For both, you are calling binary search. So log n for this, log n for this. 2 log n, 2 into log n. Time complexity. Big of 2 log n. Okay. And space complexity is, are you taking any extra array to get your answer? Yes, you are taking an extra array. Here I'm not taking an extra array. Here I'm not taking simple variable you are taking. So for that, space complexity would be constant, order of one itself. But yeah, here we are having some array, right? Here also we are having this array. So space complexity would be, but this array actually doesn't depend on the, you can say that array size, whatever is given, it's constant. It's 2 only. So the time complexity is also constant in this case, right? If you want to copy paste, if you want to submit your answer here, so let's copy paste this. We are having search range. So in this first position, this is last position, and this is our first and last position. If I run this, let's see what is happening here. You got an error. So in this, it is returning what? Search range. It is returning an array. So let's copy paste this thing there. Let's copy paste this. And for first occurrence and last occurrence, first and last position, just copy paste this code as well in this class out of this method, obviously here. Okay, let's try to run this and see what is happening. So yeah, we got it accepted. Every case we have passed every case. So if you submit it, let's try to submit it and see what is happening. So yeah, we got it accepted, right? So you can analyze the complexity as well, but for that you have to take the premium you get subscription for this lead code, right? It will show you that thing also. Let's find out lower bound, upper bound, and that's it. Lower bound will give you the first occurrence, upper bound -1 will give you last occurrence, right? So let's, if you change the name, or don't change the name, let's just comment out these things, and we'll simply go for first lower bound. So we just copy paste whatever the, here the code of lower bound, and we simply copy paste the code for upper bound after this for upper bound, right? Now first and last position. So let's have the same method here, the same thing. first and last position, and this method will call upper bound and lower bound rather than first position and last position. So at first I'm calling lower bound to get the first position, right? And then I'm calling upper bound. Upper bound, but it will give upper bound -1. At last you have to do -1 to get the last occurrence. So same if first or the lower bound is 0, sorry, -1, we cannot change it. But the thing is, here you have to take care of that edge cases as well. So what are those edge cases? Here in the lower bound, obviously you delete this, and at first we are having, suppose, lower bound is equal to -1. Then this mid is equal to this. If it's greater than equal to this, then obviously lower bound means that the smallest index that would be greater than or equal to this. So smallest index would be in the left half. So high is equal to this, else this is equal to this, and then return whatever the lower bound at last. So if this is the case, then it may be our answer. So here we can just update lower bound is equal to whatever the mid is. It may be our answer first. It may be the first occurrence, but we are not sure. Otherwise, if you don't want to take this LB as another variable just to save the space, you can go for return low as well here. That is also fine, right? And upper bound is array dot length -1. No, we change it. Upper bound should be -1 at first. So, or let's keep it as it is, because if you're going for lower bound, upper bound, in that case, we know that we take the hypothetical value array dot length. So rather than -1, you can change it. Better to take it same like array, whatever the length of the array. We know this happens when you go for lower bound and upper bound. It's not correct to get to write here -1. So in upper bound also, this is the case. If this is greater than, then maybe your answer, but upper bound may be in the, your answer may be in the left part, right? So high is equal to this, and this is low is equal to mid plus 1 in this case, and return UV. But here, now after calling this lower bound, let's suppose I'm taking not first here, I'm just taking here lower bound. So LB, simple. You have to check the edge cases as well. If this lower bound equal to array dot length, sorry, it's nums dot length, or second case is this nums of LB, whatever the lower bound you will be given, at that it's not equal to the target element. In that case, we can say that element does not exist. It will simply return -1. So same case you can take here, new -1. Or if you're not getting why this new in -1, simple method is, okay, let's take an array -1, return result. Simple. Return this array result. This is -1. Fine, if this is the case, right? Otherwise, what you need to do, don't need to check this thing. Otherwise, simply return, here we have lower bound, upper bound, -1. Or if you don't want to return this thing, if you are not getting y new int and all, now if lower bound is not this, then obviously in lower bound we have some value. So this call the upper bound as well. So int, take a variable upper bound is equal to, let's call here the method upper bound passing the array names and nums and target. So it will give you upper bound. Now we have two values. One is in this LB, one is in UB. So we can assign this. So what we can do? Result of, sorry, not return, it's result. Result of 0 is equal to whatever the lower bound, and result of 1 is equal to whatever the upper bound. And then simply return result. That's it. But yeah, if you don't want to take this much of headache like this and this, simply in one line you can return this. Okay, sorry, not upper bound -1. Take care of this thing. Last occurrence would be upper bound -1. Now return result. and that's it. If you're returning result, it will give, we will get this in the answer, and simply print this. Okay. If you don't want to take a second array, simply here also you can take system.out.println. I don't want to take a answer array here. Arrays dot toString, and here I can simply pass. I can simply call this. So here just call this. So don't need to take another array. If you want to, like, you can say minimize the space in that case, right? Okay. So I'm calling here first and last position, this method, and this is calling again lower bound and upper bound. Let's run this and see. Target is 1. Lower bound, upper bound for 1 is, we know it's 0, 0. So it will give you 0, 0. Okay, it's working fine. Let's check for 3. Let's run this, and it's 1 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 and 5. Okay, it's working fine. If I go for 31, let's run this. If it's 31, then -1, -1. Yes. And if it's suppose 2, then also it's -1, -1. If you want to check how this thing is running, you can just dry run this. First, you can just debug this. You know how to debug, just add some breakpoint and step over, and you can see how this program is running. Or better way is dry run this. Write down on a piece of paper, and you have to be your own debugger. Dry run that. You will get the actual working of this thing. So this is that you can say the third uh, way to get first and last occurrence. You can also submit this, right? So I have told you how to submit. Okay, just run that first, check the test cases, and then submit. Okay, now see one thing. We were using binary search to find first and last position. So first position is this, method for last position is this, and in first and last position in this method we just call first and last position, and that's it. But the thing is there is so much duplicacy of the code. See, everything is same in both the, if you check here, first and last position. Only the difference is, see, in this part, if mid is equal to target, in this case, first is equal to mid and high is equal to mid minus 1. In last position, if mid is equal to target, then last is equal to mid, low is equal to mid plus 1. Only this is the difference. Else if this condition is same, else this part is same, and we are returning here first and here we're returning last. So can we call only one method? Can we just remove this redundancy? Why to write down both two methods? Can we do something like this? One method only, and just apply some check there. If you want to find out first occurrence, then apply this condition. If you want to find out last occurrence, then apply this condition. Otherwise, all the other conditions are same. Yes. So pause the video and try this out. Now, let's see. We are just doing what we just comment out this thing. In first and last position, this is the case, and here I'm calling not first and last. Here I'm simply calling int first is equal to, I'm just taking the name here, comment out this, taking the name here, int first is equal to uh, find position, that's it, or search position, search position, and I'm passing the array, that is nums, and the target. And one more thing, you have to find out, if you are finding the first occurrence, so you have to find out, you have to pass, yes, I'm finding first occurrence, so you can pass some value like third is something like true, like finding first position, finding first index, true, right? So let's have a method here, search static int and search position, and here I'm just taking first is arrays nums, then int target, and boolean find Find first occurrence or first position. We are taking here position. So let's take find first position. Something like this. And again, if you want to go for, see, go for the last. So int, again call the same method search position, but here just find first position. No. So pass here false. Based on that, just update this thing, search position, right? So here everything would be same. This, while this condition mid is same. So let's just copy paste this only. We are having low, high, and don't take last is equal to -1. Delete this. Low is less than equal to high, then mid is equal to this. Okay, fine. Now we cannot directly write down this condition first. If mid is equal to target, then this, because these two conditions are different in both the cases. These two conditions are same. Else if this and this. So first write down these two conditions. So we can write down this thing. If this nums of mid is greater than the target. If it's greater than, then you have to do, you can search obviously in the left half. So high is equal to mid minus 1, that we know. If this is the case, then this thing. Else, if this nums of mid is less than the target, then we know the target is definitely in the right half. In that case, so low becomes mid plus 1. Now one case is still left. Else, if it's equal to mid. Else, if it's equal to mid. These two cases are different. In first case, if it's equal to mid, then first occurrence would be definitely in the left half. In last, if you want to find out last position, then if it's equal to mid, then last occurrence is definitely in the right half. So now you have to apply the check. Else now check if this find first position is true, or you can simply say like is equal to true, but don't need to write down this thing. This line is enough for this. If it's true, means you have to find out first position. In that case, in else part, in else part, first we know what is the situation. If this is not true, this is not true, then mid is equal to target. Then it may be our answer. So first you have to change. First you have to change. Suppose we have here answer int, and we have suppose here pos position at first. So else pos is equal to whatever the mid is. It may be our answer. We are not sure. Now change. If this is true, find first position is true, then first occurrence would be definitely in the left half. So you have to change. You have to do high is equal to mid minus 1. Yes. Else just do low is equal to mid plus 1. Simple. And we are changing the position here. And at last we just return this POS. Yes. So when you're calling search position with this true, it will return first. If first is -1, so you can just write down here this condition. Don't need to go further. Don't need to call second time the search position. So if it's -1, we can simply return here. We can just take it. Suppose we just take a result is equal to -1, and you simply return here whatever the result is. Simple. If it is not -1, in that case, at first we can say here the position is -1. In search position, at first let's initialize position is -1, because if you'll not get anything, definitely position would be -1. So you have to initialize it with -1. And at last, now then, after this, return whatever the position is. Once this loop is over, return position, and that's it. Now, if this first is -1, or you can say whatever position it will return, it's -1, then return simply the result, that is -1, -1. Otherwise, we call last for search position, and here we uh, obviously pass false. And then if you don't return something like this, comment out this. So we can do one thing. result of, sorry, not return, it's result of 0 is equal to whatever the first, and the result of 1 is equal to whatever the last. And now we simply return the result. Simple. That's it. So we have just called only one method now based on this check, right? That's it. No first position, last position, two methods. And in main, we are just calling here first and last position, and it will return some array obviously. So we are just calling arrays to string first and last position. Let's search for 2. Let's run this, and it should give you -1 because there is no 2. So -1 fine. Let's search for 3. So it will give you the value, the index value 1 and 5. So 1, 2, 3, 4, 5. Yes, correct. If you go for 7, it will give you obviously the index is 0, 1, 2, 3, 4, 5, 6, 7, 7, 7. Yes, it's correct. So this is how you can optimize it a little bit. Rather than calling two method, only one method you pass, just based on some pass some checking condition, whether you're finding the first position or the last position. That's it. Okay, now there's one more question. See, you have to find out number of occurrence. Number of occurrence means you have given a sorted array or list of integer arr of size n and an integer x. You have to find out total number of occurrence of x in the array. And this question is being asked in the companies, even Amazon. So these are the companies where this question has been asked, right? So it's very simple, I guess. You can easily answer this question. Till now, we have seen whatever questions based on that also already you can give this answer this question. See, input n is 7, x is 3. Array is this. So how many times 3 is there in this array? 1 and 2. Output is 2. Yes. So see, how can you can easily, I guess, solve this. If you know the first occurrence of 3 and the last occurrence of 3, then last minus first plus 1. That's it. Is it or not? Yes. See, suppose I have this array and my x is equal to 20. My element is 20. I want to find out how many times this 20 is there in this array, number of occurrence of 20. So we know the array is something like this 5, 6, 7, 8, 9. The index is something like this. Now, if you want to find out number of occurrences, then the very simple approach, it's naive approach, that brute force, is what? You start searching from first. Is this 20? No. Is this? No. No, 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 no. Yes. This is the first 20 you get. As soon as you get 20, just take a count variable at first 0. At first, suppose we have count is equal to 0, and then we'll do count is equal to 1. Count plus plus. Then go for next. It is 20? Yes. Again count plus, count plus plus. Is it 20? Yes. Again plus. Is it 20? No. And the last of the array till the last of the array, and now at least count is equal to 3. That's it. Yes. If suppose I want to find out x is equal to, my x is equal to 2. So again check from the first. Is this 2? No. Is this 2? Yes. So count would be, at first count was 0. Count will become 1 now. Is this 2? No. 2, 2, 2. You check for everything, every element, and count is now 1. So it's like linear search we are doing. But obviously the time complexity in this case is order of n. Because it's linear search, we are searching each and every element from first to last. Right? Or you can do one thing, like after this 20, once you get 25, and here I'm having 30, 31, and something like this. So once I get an element greater than this 20, maybe you can stop. In if you can just put this kind of condition and break the loop and all. But still you are going from 0 till like one by one you are checking all the elements. So it would be considered as order of n in worst time. because it will increase linearly, something like the graph would be linearly something like this, right? But we want a better solution. Log n. Can we do this with log n? I guess you can do this. If you think a little bit, you can easily do this. If you know if x is 20, suppose, and if you know you can say the first occurrence of 20 and the last occurrence of 20. If you know this index 6 at 6, this is the first occurrence of 20, first position. 8 is the last position of 20. Then I can easily find out the occurrence. I think don't need to explain. 8 minus 6, then plus 1. Simple. 2 plus 1, that is 3. Simple. Yes. Same here, x is 2. X is 2, right? So first occurrence of 2 is 1. Last occurrence of this 2 is 1 itself. So both are 1, 1. So how you can get 1 minus 1? Last minus first plus 1. So that would be 1 itself. And we know that number of times 2 is in this list is arrays 1 time. So, and we have already done. Have to find out first occurrence, have to find out last occurrence. So you have to update that a little bit. Just add a count method as well. And their last occurrence minus first occurrence plus 1. That's it. So let's try out this. So let's create here a new class. What we are doing, we want to count occurrences. Count occurrence of elements. So we'll follow now the linear search first, right? So let's have an array. Array will take this one only, and the target is 7. So let's take this array only. Target is 7. Occurrence of 7 I want to find out. Right. Now, first I'll go for the linear search. So let's have a method itself is equal to count occurrence in this ARR array, and the target is whatever the target you pass there. And we can simply print at last the result. Okay, fine. Now let's define this. So it will return an int value, count occurrences, and we're passing the array. So we are having here an array and int target. So at first, we take count is equal to at first 0. So now we will move the for loop would be from first to last, right? So you can use either traditional loop or for each loop as well. Let's loop in this case for each loop. So int num, whatever the array, this. Now check if this num equal to target. In that case, just to count plus plus. Simple, right? Otherwise, don't have to do anything. And after this for each loop, whatever the count, just return that. Simple. Let's run this. For 7, it should give 1. Okay, the occurrence is 1 itself. Okay, it's fine. It's working. Now, let's go for the target is suppose 3. Let's run this. It's 1, 2, 3, 4, 5. 5 times. So yeah, 5. It's working. Now target is suppose 31. It's not present. So count is 0. So it should give 0. Yeah, it's 0. But this is linear search and obviously the time complexity is not that much great. Now go for binary search. Okay. Now let's just comment out this thing. Okay. Now let's just refactor this count occurrence using linear. Just refactor. Now let's create a new class and there we have count occurrence using binary approach. Okay. Let's just copy paste this thing as it is and we'll change accordingly because this is same. We have array and the target is this and we are calling count occurrence and all. Okay. Now in count occurrence, what you need to do first, we'll just find the first occurrence, then the last occurrence, and then just do last minus first plus 1. We know how to find out first and last occurrence. We know the thing, first and last position. We can easily find out with this search positioner method. Either separately you can find out first occurrence, last occurrence, and then do. Otherwise, this was the approach. We have modified it a little bit by passing one more argument, that is boolean, find first position or not. So we can have this thing also. So let's just copy paste the same code from this using binary. So we are having, see, first and last position we want to find out. Okay. Here the result is 0. So first is equal to this search position and this. Delete this line. And now we are having first, it's -1, then result, and last. Okay. Let's just delete this thing also. So this will give me first and last position. This is calling search position. So this is the search position method. Okay, fine. Count occurrence. Now in count occurrence, count is, let's say we have 0 at first. So we know now the first and last position from this method. So we can call this method from count occurrence, right? Just delete this thing and now just write down the code. Now we are calling this first and last position. We are passing the whatever the array and the target. Yes, this will return an array because it is returning result and result is itself an array. So to store this, we have an array itself. So we have an array, int of array, and the name is I'm taking answer is equal to this. Whatever it is returning, I'm just fetching that in this array, answer array. Now count would be what? Now suppose if this is you can say the first, it is -1. The first is -1. Then there is no, like, the element is not there. So we can simply do if answer of the first element is equal to -1, then return 0 or return count, because at first count is also 0. If this is not the case, then we do something like this. What we do is then we update. Now count becomes answer of the last occurrence is at this index 1 minus answer of 0. Just put it in the bracket and plus 1. Simple. That's it. And simply return whatever the count you have. It will return the count here and we'll print that. Let's run for this for 31. So it should return 0. Yeah, it's 0. Now again for 3, it should return 3 and 5, 5. So it's 5. If I go for 1, it should return 1 because 1 is only one time. So it's 1. If there is nothing in the array, let's run this. Now it should return 0, right? Because there's nothing in the array. And if we have 0 itself here, then also obviously there is no 0 here. So it should return 0. 0. So like this. This is one more case. But here, same, like it should be log n. Because see, here we are calling count occurrence. In count occurrence, this method we are again calling first and last position. Now go for first and last position. In this, we are calling search position, right? 2 times. One is this, one is this. So it should be 2 of log n. In search position, we have a loop, obviously while loop. It is running till low less than equal to high, but dividing by 2 each half. So it's binary. So basically log n. So log n and log n. It is like 2 log n because 2 times we are calling this, right? That's it. Complexity would be 2 log n with some plus some constant values, maybe 3, 4, 5, or 10, 15. But we ignore these things. We ignore constant. So complexity would be, we take it log n itself, base 2. So that is much better than the previous, that is order of n. Okay, so this is the second approach to find out to count the occurrences of an element in a sorted array. And if I'll copy paste my code here, it's n and we are having x. So we are having, rather than target, we are having x here. So let's call it, we are passing x. Okay. Now obviously you have to copy paste these things also, these methods. So we just copy paste these things also. Search position, target, and this. Let's run this and see if it's working or not. There are 15 test cases. So yeah, we are done with all the test cases, and if you want to submit this code, then let's see it's working or not. Okay, like this you can submit it, right? So you are better than 91% of the students. Maybe in space complexity you can do something better in this case. So I hope you got these type of questions. We'll see more practice questions as well, but you also try out now. Go for maybe on LeetCode or on some other coding platform. Go for these sorted arrays questions asked in top tech companies or these things. And just keep in mind one thing: if this is sorted array is given, apply binary search. You will get optimal solution. Maybe you have to modify that binary search a little bit. And if you know about lower bound, upper bound, you can solve easily many questions if you aware about that technique, right? So now that's it for this lecture. Now we'll see you in the next lecture with some more practice problems. So till then, bye bye. Take care.